Hello students, in this video I cover item 4 of the book Effective Java, enforce non-instantiability with private constructor. So what would you need to make a class as non-instantiable? For starters, if you're creating utility classes, it makes sense to make your constructor private. So to give you an example, the math class in Java has maybe 4 or 5 static fields, and the rest of the methods are static. You can also use this approach, which I've already shown in several of my other videos, is to create static factory methods. And so when you have cases where you have instant controlled, it may make sense to do this as well. And so the reason why you do this primarily in the case of utility classes, for example, is that a particular class doesn't necessarily need instances to do work. So you have heard, or I'm assuming that you have heard, the term helper methods. So when you have helper methods in a class, and a class only contains helper methods, and are stateless, which means that you don't have any variables that can change the value. So when you have variables in a class, that means that the state of the object, which is defined by the variable values, changes, then it's no stateless anymore. So if this is the case, then this will not apply. But if you don't have any fields, or you don't have the need to have fields other than constants, then it make perfect sense to say, I don't want to allow instances of this class to be created, because every instance will be the same. It will be making copies of the same thing over and over and over. And so for these cases, it makes sense. So singletons, which I covered in a previous video, does the same thing, enforce non-instantiability by private constructor, but I am not talking about singletons in this video. I'm talking about utility classes, which are basically classes that have nothing but static methods. And so one of the things that some people find kind of confusing about this is that the idiom appears to be counterintuitive, because you have to provide a constructor for the sole purpose of not allowing the constructor to be called. So it's basically creating this specialized method for the only purpose of restricting calling it, or from just flat out prohibiting being able to call this method. So because of that, it sounds counterintuitive. But consider the benefits I just outlined for you. You don't need to create multiple copies of something that is going to be always the same thing. Also, this idiom has side effect. And the side effect is that it prevents a class from being subtyped. So you cannot create children classes of this. So in the case of utilities, this makes perfect sense. You don't need to extend a utility, a helper method. You need to create more helper methods, but you don't need to extend helper methods. For other cases, when you create instances, then consider composition over inheritance, which is another good topic that I will cover in the future. But I do want to show you something before I proceed, and I'm pretty sure that is a question in some of your minds, is that why not use abstract classes for this purpose? After all, an abstract class you cannot create instances of an abstract class. Well, this is not true. This is not completely true. So I have created this abstract class named abstract class, and I cannot call this constructor. So I cannot create instances of my abstract class directly. However, you create abstract classes because you want concrete classes to extend it to complete the implementation. And so there may be some different things that you want to be able to implement in the subclasses, so you allow subtyping, and you will have multiple classes adding the different final touches. But from the constructor of the child class, you can invoke the constructor of this abstract class. So using abstract classes for this purpose doesn't work for this reason. So when you have a typical utility class, will look something like this. So you will create your class, you will create your constructor, which will be private, and in here you will have a collection of static functions, static methods. Now, one thing that I do that is not required is include this assertion error on the constructor. And the reason why I do this is because it's an insurance policy in case from this class or from a nested class I accidentally invoke the constructor. Also, I do this to prevent instantiation via reflection. And so to stop that reflection attack, if this constructor will ever be invoked, then this assertion error will be thrown, and then basically the application just dies there. So that is basically it. This item is basically a single page. It's very short, and this is all there is to it. So I hope that you enjoyed this video as much as I enjoyed making it for you. Please provide any comments below, especially for ideas for new contents that don't necessarily have to do with this book. I will also appreciate any feedback on suggestions to improve the quality of the contents. And so I'm looking forward to read your comments. With that, have a great day. I'll see you next time, and don't forget to subscribe.